All right, let's look at a couple of the examples from the homework last night. So determine if the sequence is arithmetic, explain why or why not. So to be arithmetic, you have to have what's called a common difference. It's basically just the rate of change. So we're looking to see, were we adding a constant value each time to this sequence? And so since I added 4, added 5, added 6, this one is not arithmetic. And the reason why is there is no common difference. So since there's no common difference, it's not going to be arithmetic. All right, let's look at number 3. So they want us to find the common difference, then write the explicit rule. So that's going to be this one up here. And so to do the explicit rule, all we need to do is plug in the parameters d and the parameter a sub 1. So d, we already said, is the common difference, what we're adding or subtracting. And then a1 is the first value, the initial value of the sequence. So let's see here. Let's see what d is. Let's see what a sub 1 is. So d, what we're adding each time, looks like it's 3. We're adding 3 to get to each term. And then the first term of the sequence, the initial term, is 12. So my explicit rule is going to be a sub n equals 3 times n minus 1 plus 12. Now for this one, they want us to find the next 3 terms and write the recursive rule. So for the recursive rule, it's the same thing. We're going to plug in d. We're going to plug in what d is, and we're going to plug in what a sub 1 is. Everything else just stays the same. So let's find our 2 parameters. So d is negative 10, and a sub 1 is 20. So the recursive rule would be a sub n equals a sub n minus 1 plus d, comma, a sub 1 equals, not d. We want to plug in what d actually is. So plus negative 10, comma, a sub 1 equals 20. So I'm literally just rewriting this entire rule, replacing d and a sub 1. And then the next 3 terms, if I'm adding negative 10 each time, would be negative 20, negative 30, and negative 40. All right, they want me to find the 42nd term. So to find indicated terms, we always use the explicit rule. So we need to plug in a sub n d times n minus 1 plus a sub 1. So we need to plug in a sub 1, which is 10, and d, which is 6. So we're going to do 6 times n minus 1 plus 10. That's our formula. And they want us to find the 42nd term. So we're just going to plug 42 in for n. And then we just evaluate. It's just like evaluating a function. So 6 times 41 plus 10. 6 times 41 is going to be 246 plus 10. So the 42nd term is going to be 256. So the steps were write the explicit rule, and then plug in 42 for n. Write the explicit rule, plug 42 in for n. All right, and then for the next one, we have a word problem. So a swim pass is $30 for the month. Each month after that, the cost is $20 per month. So Riley wants to swim for 12 months. This sequence is arithmetic. What is the first term? So the first term of the sequence is her first month, which is 30. The common difference is going to be 20, because that's what she's paying per month. And then the explicit rule would be a sub n equals d times n minus 1 plus a sub 1. So I just plugged those into my formula. And they want to know the 12th term. So I'm going to do a sub 12 equals 20 times 12 minus 1 plus 30. And so mathematically, that is going to end up being $250 for the first year of swimming. Oh, sorry. That would be the answer to 12. Give an example of an arithmetic sequence whose common difference is -4. So a sub 1 could be anything. Let's say a sub 1 is 10. If my common difference is -4, my next term would be 6. My next term would be 2, -2, -6, and then we can just do a dot, dot, dot to show that it goes on forever. And the last one's not arithmetic because we're not adding a common value. This one's actually going to be geometric, which we're going to talk about in our next lesson, because it's multiplying by 2, and there's no addition. To be arithmetic, there has to be addition or subtraction, which this problem doesn't have.